Hello friends, today we will see the example based on normalization. We will see how to normalize a given relation and based on its functional dependencies. Okay. Now last time we have seen what is normalization. Again I am repeating. Normalization is the process for eliminating the problems of insertion, deletion and modification. In the terms of, again we will solve the problem of redundancies. Now in normalization we will have one relation. Let's say we have relation here, relation R A B C D E F G H I J. That is one relation having the 5 6 7 8 9 10 attributes. Okay, and we are going to decompose this original relation or a table into the multiple tables where we will solve the problem of insertion, deletion and modification and as well as redundancy. Okay, so we are going to convert it into the normalized table. Again I am repeating what is 1NF. I have given the characteristics of the 1NF in the last video. What is 2NF? 2NF should be, if relation is said to be in 2NF, it is if it is free from partial functional dependency. What is partial functional dependency? When the key attributes determine non-key attribute. Let's say AB is a key, okay, and in this case AB is a key. If it is part of the key determines non-key attribute. Okay, so A comma B are key attributes. When they will determine non-key attributes, like example you can say here A determines DE. Here exists partial dependency because A is a part of key and D and E are non-key attributes. So here partial dependency exists. Okay. Now when there is a partial dependency, table is not in 2NF, it is in 1NF. If there is no partial dependency, then relation is in 2NF. Okay. Now when relation is having if we can say that when relation is in 3NF, when the relation is free from transitive functional dependency. What is transitive functional dependency? When there is a relationship between non-key attributes. Okay, let's see in the example. We have here A comma B are key attributes and all other are non-key attributes. So where you can see the relationship between non-key attributes. So here F determines GH. F is non-key attribute. G and H are also non-key attribute. Here there exists transitive dependency. Okay. Again, D is also non-key attribute and I and J also are non-key attributes. Here also transitive dependency exists. Okay. Now AB determines C. Here no dependency, no partial as well as no transitive dependency because AB is a key. Okay. And here B determines F. Here again partial dependency exists. Why? Because you can see here B is a part of key and F is non-key attribute. Okay. Now understanding 3NF. Now you can see here design by synthesis. What is design by synthesis? If a table consists of few partial dependencies, it is saying that combine LHS and RHS of functional dependency. Let's say this is one of the functional dependency. We can combine this and add a table that consists primary key attribute if it is not in a part of the above tables. Okay. Now this is very important, design by synthesis. Now we are going to convert this relation into the normalized relationship, normalized tables. Okay. So we are going to have here normalization. Okay. Now before doing normalization, we should understand what is the minimum normal form of this relation or this table. What is the minimum normal form? Okay, that is a question. So we will check. So by default this relation is in 1NF. So every relation which is given a functional dependency, it is assumed to be in 1NF in exam. Why? Because see, the every attribute is a unique. What is the first characteristics of 1NF? So in the previous videos I have given the 5 characteristics of the 1NF. By seeing that we can say that relation is in 1NF. Okay, now this is assumed to be in 1NF. So every relation which is given in this form will have minimum form is 1NF. Now we have to check whether it is in 2NF or not. How to check whether it is in 2NF or not? If there exists a partial, if there not exist partial dependency, then we can say that relation is in 2NF. Now we will check whether here partial dependency or not. We have already seen that. Here you can see that here partial dependency exists because part of key attribute determining non-key attribute. Again here part of key attribute determining non-key attribute means what? Here partial dependency exists. Only one functional dependency having partial dependency, it is sufficient to say that relation is not in 2NF. Now the lowest form of this relationship is in 1NF. So we have to convert it in 2NF. Okay. After converting to NF, we can make 3NF. Okay, after 3NF, we can make into BCNF. Now, if I ask a question, the relation is in 3NF or not? So the answer will be definitely not, because it is not in 2NF. So when relationship is in 3NF, it must be in 2NF. And what are the characteristics of 3NF to be in 3NF? First thing is, it should be free from transitive functional dependency. What is transitive functional dependency? There should not be any relationship between non-key attribute. Like in this case, if there is a relationship between non-key attributes, we can say this transitive dependency. And when there is a transitive dependency, we can say that table is not in 3NF. Okay, so now how to convert this relation into 2NF according to the given design by synthesis? So we will start. So we will, let's assume we are going to make some relation. That is, R1 is the first table, R2 is the second table, and let's say R3 is the third table. Okay, now we will start with the first functional dependency. Okay, this is very important to understand because this is very important step to convert into the first NF, second NF. Okay, now AB determines C is a primary key is one relation functional dependency determines AB determines C. Okay, now understand, first we will concentrate, or we will look the functional dependency which is violating 2b into NF. So which are the functional dependency which are violating 2b into NF? That is what? Second, because here we have partial dependency. Again here we have partial dependency, means what? Those functional dependencies are causing table not to be into NF. That's why we will start with A determines DE. So relation R, we will write here functional dependency which is violating A determines DE. Now assume we will combine the LHS and RHS, or another method is we will find out A closure. So what is A closure here? In this case, A, D, E. Okay. So now again D determines IJ. So I can write here IJ. Okay. Now what we will do, again the another method is we have added ADE, IJ, because D determines IJ, so we have added, and here the key in the relation will be A. Okay, now we will move towards R2, which is the second relationship is violating B determines F. So R2 is equal to, I will calculate B closure is equal to, I will write here B F, and F determines GH. Okay, so I will write here GH. So I will not have any more because no G and H on the left hand side. So here key will be by default B. Okay. Now R3. So according to the rule, what is the now we have covered A determines DE. We have covered this. Okay. B determines F. We have covered here. Again F determines GH. We have covered here. Determines IJ. We have covered in R1. Okay. But we have left with AB determines C, and that is a functional dependency about the key, because AB is here. For this relation, AB is a key, so I will write down here AB closure, or I will write down AB, so AB and C. Okay, so now here key will be AB. So now we have decomposed original relation R into three tables, that is R1, R2 and R3. Okay, now we will also divide those functional dependencies. Now R1 is having functional dependency A determines DE, and again D determines IJ. Hope it is visible. Now what is R2? R2 is having B determines F, and F determines GH. Okay, and R3 have one functional dependency, that is AB determines C. Okay, now it's very important to understand. Now we have to check whether this relation R1 is in 2NF or not. How to check? Here for those functional dependencies, there should not exist any functional dependency, sorry, not any partial dependency. Okay, what is key here? Key is A. In this case, key is A. So A determines DE. Can we say that here partial dependency exists? No, because A is a key only. A is not part of key because A is key here. So we will say no PD as well as no transitive. Can you see here transitive dependency? No, so no TD. Okay. Here you can get D determines IJ. What you can get here? Transitive dependency, because relationship non-key attribute is determining non-key attribute. Okay. Now we will move towards, okay, now R1. Now we can say here no partial dependency exists. Then we can say that this relation is in R1 is in which NF? 2NF. Very important to note. Okay. So R1 is in 2NF. It can be in 3NF, but it is not in 3NF. Why? Because here exists transitive dependency. Okay. Now, if we want to make this relation into the 3NF, then we should be removing transitive dependency. Okay. Now let's think about R2. What is the key in here? A, B is a key in this case. Okay. Now we will check for this functional dependencies of R2. Here B is a key. B determines F. Can you say here any transitive or partial dependency? Here is no partial dependency. Why? Because B is not part of key. B is complete key determining non-key attribute. You can say that no transitive, no partial dependency, as well as here no TD. TD means what? Transitive dependency. Okay. And think about this relation F determines GH. Can you find here any partial or transitive dependency? So here F is not part of key, so definitely no partial dependency. But here is an F is a non-key attribute and GH is a non-key attribute. You can say that here transitive dependency. So you can say that R2 is in 2NF. It is not in 3NF. Why? Because in this functional dependency you are getting transitive dependency. Okay. So only one functional dependency having transitive dependency is sufficient to say that relationship is not in 3NF. Now what is about the R3? So now only one functional dependency, that is AB determines C. And what is the AB? AB is a key. Here can you say any partial dependency here? No, because AB is a complete key. You will say here no partial dependency. Can you see here transitive dependency? Is there any relationship between non-key attribute? So AB is not non-key attribute. C is non-key attribute. Okay. And AB is super key. Okay. So you can say that here no partial, no transitive dependency. Okay, means what? This R3 is in 2NF, as well as there exists no transitive dependency. You can say that this R2 is in 3NF. Okay, so in this way we have decomposed relation R A B C D E F G H I J into the three tables, that those are R1, R2 and R3. So the R1 relation consists of how many attributes? 1, 2, 3, 4, 5 attributes having like this. So you are getting 5 attributes: A, D, E, okay, I, and then J. Okay, so 5 attributes. What about the R2? R2 is having the, what are the attributes of R2? 4 attributes: B, F, G, and H. Which are the attributes of R3? So attributes of R3 are A, B, and C. Okay, so very simple but very important to understand: A, B, C. So we have converted normalized tables R1, R2 and R3. Now we have decomposed those R1, R2, R3. Okay, now we can convert R1 and R2 into 3NF. We will see in the next video how to convert the relation into the 3NF. Then we have to when we have to convert into 3NF, then we should be removing transitive dependency. We should be removing here transitive dependency. Okay, it's very simple, but understand this decomposition can be of two types. So first is called, now decomposition is called dependency preserving decomposition, as well as lossless decomposition. Okay, so let's see what is functional dependency preserving decomposition as well as lossless decomposition. Hope you have understood in this video how we have normalized this relation. Now before the requirement was, we are having the relation having functional dependencies that are extracted, that are in canonical form, and those are derived by the database designers, and we have converted by, the process was designed by synthesis. We have understood partial dependency as well as transitive dependency, and we have tried to remove partial dependency, and we have converted R1, R2 and R3 based on, we have took the first functional dependency which is having which is violating partial dependency, which is violating having partial dependency. Again second, then we have took the first key. Okay, so if you have liked this video, please subscribe my channel with notification button, and like, if you have any question, comment, any doubt, you can ask in a comment box. So thank you very much. Now just we will see what is lossless as well as functional dependency preserving property. Now we will convert those relation which are in now 2NF, we will convert into 3NF. Now how to convert in 3NF? Now again let's see. R1 and R2 are not in 3NF, so we will be converting R2 and R1 into 3NF. Okay, which are the functional dependency which is causing R1 not to be in 3NF? That is what? This transitive dependency. So we have to remove this transitive functional dependency. How to remove? Now we will decompose R1 into further two tables. Let's decompose R1 into R11 as well as R12, and let's convert R2 into two relation, that is R21 and R22. Okay. Now understand. Now I have all functional dependencies originally. So I have originally in this table. Just note this, and I am just cleaning, and just I will solve this problem, how to convert this relation into 3NF. Okay. Now we will have R1 like this. What is R1 here? A D E I J. Okay, those are the having R1. And what are the functional dependencies of R1? A determines DE and D determines IJ. Okay. Okay. Now this is having problem. Okay. So now we will convert R1 into two tables as I have said. First will be R12 and R11 and R12. So now which are the attributes of R1? Now let's make this table separately because we have to remove this transitive functional dependency. Okay. So now in second one we have R11. We can write down first functional dependency, that is A D E. Okay. Directly I am adding left hand and right hand side of this R1. Here A is a key because A determines DE, and in R12 I will write here D determines IJ, so I will directly write DIJ. Okay. So those are the two relation. Okay. ADE and DIJ. Here key is a D and here key is a A. Now what is the functional dependency for R1? It becomes A determines DE and here it determines D determines IJ. Okay. Now can you say here any transitive dependency here? Can you say any functional transitive dependency? No, because A and A is a key, D is a non-key, because no here no partial dependency as well as no transitive dependency. D determines IJ. Initially when the key was only A, that time D and IJ were non-key attributes. But as you made different special relation or table for R1 to Dij, you can say that D is a key and IJ is a non-key. D is a candidate key, D is a super key, D is a primary key, A is a super key, A is a primary key, A is a candidate key. So you can easily say that this is not having partial dependency, no PD, no TD. Okay, no TD. Here also no PD and no TD. So you can say that this R11 and R12 relation not in. So that's why no PD, no TD means what? It is in 2NF as well as it comes in 3NF. Also it comes in BCNF because here no, this is a super key or candidate key. Again it is in 2NF, it is in 3NF, it is in BCNF. Okay, this is third normal form. Okay, now we will convert. Next is what? R2. Now we have to make here R2. Hope you are you can see on the board. So we will make R2 into two relation, that is R21 and we will make R22. So now which is the functional dependency which is causing transitive dependency, that is F determines GH. So we will make two normalized tables. We will add LHS and RHS of this first functional dependency and we will create separate table, that is BF. Here is a B is a key. Okay. And in another example we will be having R22, what is what? F determines GH. So I will write here F GH, where F is a primary key and GH is a all non-key attributes. So I will write here functional dependency. Hope you can see. Okay. So here R2 we have decomposed R21 and R22. B determines F. We have converted, added left hand and right hand side of this. We have created BF, or you can calculate B closure. Again, we cannot have B closure here. We will add left hand side, right hand side of this BF, and we will having F GH. Left hand side is F, right hand side is GH. What is functional dependency for this R21? That is what? B determines F. What is for R22? That is what? F determines GH. So now we will verify whether it is in 3NF or not. So for 3NF it should not be having any transitive dependency. So can you get any transitive dependency? No, because it is not having, it is not non-key attribute, it is also not key attribute. So here no TD as well as no PD for both. No TD, no PD means what? You can say that this is in 3NF. So relation R21 and R22 are in 3NF. They are in 2NF as well as they are in B, C and F. Okay. Why? Because B is a candidate key or super key and F is also super key. Okay. So now we have decomposed relation A, B, C, D, E, F, G, H, I, J into how many tables? 1, 2, 3, 4, 5 relation or 5 tables. So let's write that. So relation R11 is like this. R11 having attributes. R11 is where is R11? You can see here ADE. Okay. Then R12 is DIJ, where A is a key. In DIJ, D is a key. Then we have R21. R21 is having BF, where is B is a key. And then I will write R22. So R22 is having, what is the key of R22? BFGH, FGH, where F is a key. Then I have R3. So what is R3? So we have not decomposed R3. So R3 is having A, B, C. So you can see here AB is a key for R3. So we have 5 relations. So we have normalized this relation into 3NF minimum form, that is 3NF, that is R11, R12, R21, R22 and R3. So we have decomposed those tables into 3NF. Now as I said, there are 2 properties. We are going to see that what is lossless join, what is lossless decomposition as well as functional dependency decomposition, because those are the very important properties of normalization. In 3NF, we will up to 3NF we can get both, more chance that we can get lossless decomposition as well as functional dependency preserving decomposition. But as we move towards BCNF and above, then we can see that there is not there will be low chances of having either one property will be fulfilled. Okay, let's see in the next video. Now for your understanding, just look at this diagram. If relation is in 1NF, okay, so we will be showing in this. If it is in 2NF, it must be in 1NF. If relation or table is in 3NF, it should be in 2NF as well as in 1NF. If relation is in BCNF, it should be in 3NF as well as 2NF and 1NF. Again, I am repeating. 2NF means what? It should be free from partial dependency. It is in 3NF means what? It should be free from transitive functional dependency. It is in BCNF means what? BCNF means what? Left hand side of this attribute alpha determines beta. This should be a super key. If it is happens, then we can say that relationship is in BCNF. Okay. Now BCNF focuses on candidate keys. So I will also show the difference between 3NF as well as BCNF. Okay. So thank you very much. If you like this decomposition and normalization using this example, please subscribe my channel. Do comment. If you have any question, you can ask in comment box, and we will solve the different examples asked in a gate. So what are the types of question asked in gate? So they will give you relation and functional dependencies, and they will ask whether this relationship is in 3NF. Find out the lowest minimum form of this functional dependency. Okay, and they will ask different questions like that. So we are going to see the gate questions, NET questions and NIC questions. Thank you very much once again. Stop.